Welcome, math lovers, to another video of the series 100 Problems from Around the World. Today we are visiting a very prestigious Math Olympiad, which is India Math Olympiad of 2016, from the final national phase, and we will see problem number 1, which obviously should be the easiest problem on the test on the first day, and it is a geometry problem, and let's see together a possible solution of it. So, let ABC be a triangle in which AB is equal to AC. Suppose the orthocenter of the triangle lies on the incircle. Find the ratio AB divided by BC. Now, I have often said in this channel that geometry is not my strong point, and whenever I was, let's say, back in my days when I used to participate in Math Olympiad contests, whenever I had the geometry problems, I tried to solve them with a coordinative plan setup. So I was not very good at synthetical solutions. So today I am going to do the same thing, let's say, that I have always done, try to solve this problem not synthetically but by coordinative plan setup. And it is a very powerful tool, and in many cases, well, the calculations are a little bit heavy, but in many cases it can be done even this way. So without further ado, let's see the solution that I have thought about this problem. I am certain that many of you might find much more elegant and beautiful solutions, which, if you want, you can share with us in the comment section. So again, we rewrite the request of this problem for a triangle ABC, and we make over here a simple diagram. We have AB is equal to AC, and the orthocenter of the triangle lies on in circle, and we are asked to find the ratio between AB and BC. Now, as I said, first of all, let's put everything in a coordinative plan setup, x, o, y, and we will get that. Point B, we set it with coordinates minus a, 0. Point C, it is symmetrical with the OY line, and C will have the coordinates a0. A will have the coordinates 0b, and then in this case we will have that AB, which is the side of this triangle, will be equal to a squared plus b squared, square root of it, and given that ab is equal to ac, we will have them, both of them will be equal to the square root of a squared plus b squared. We will put let's say the altitude ah equal to b, let's say this altitude from side A, and bc in this case will be equal to 2a. Now, in order to find some relations for calculating the ratio ABBC, we first start by calculating in two different ways the area of triangle ABC. So we'll have that area of triangle ABC is equal to PR, which is a very well-known formula, where P is the semi-perimeter of the triangle and R is the incircle radius. So the incircle that we have shown over here with center I. So in this case, we will have that the semi-perimeter will be equal to 1 divided by 2 of 2a, which is side BC, plus 2 times side AB, which is square root of a squared plus b squared multiplied by the radius r. But in the same time, we know that for triangle ABC, the area of this triangle is equal to base times altitude divided by 2, so it is equal to AH times BC divided by 2. We have that AH is equal to B, as we put over here, and BC is equal to 2A. So in this case, area of triangle ABC will be equal to AB. Now, equalizing both these equations, we will get that A plus square root of A squared plus B squared times R is equal to AB, or that R, which is the incircle radius, is equal to AB divided by A plus square root of A squared plus B squared. Now, we have put over here H is the contact point between the altitude from side A and the incircle radius with center I. Now, given that H lies on the circle and it is the altitude from point A, this means that the x coordinate of point H is 0 and the y coordinate of point H is equal to 2r, equal to the diameter on the incircle. As we said, xh is equal to 0. Now, we can express epsilon h, which is, let's say, the epsilon coordinate of point h, which is the point where the altitude from A touches in circle with center I, and on the altitude, so we said that we can express epsilon of h independence of A and B. Now we have that line AC passes through 2 points. Through point A, which has coordinates 0 and B, and through point C, who has coordinates coordinates A and 0. Its slope, in this case, will be equal to minus B divided by A. Now, if, let's say, we know that the altitude from B is perpendicular to AC, and it passes, let's say, in through the orthocenter. So also the altitude from B passes through H and is perpendicular to AC. Now, given that the slope of AC is equal to minus B divided by A, the slope of BH will be the negative reciprocal of minus B divided by A, so will be equal to A divided by B. The equation of line BH is epsilon minus epsilon of B is equal by slope, which multiplies x minus x of B. Now we know that epsilon of B is 0, x of B is equal to A, and the slope is equal to A divided by B. So by this we can derive the equation of the line BH, which is epsilon is equal to A divided by B times x plus A. So now, given that H lies on the line BH, we can find the epsilon of H, which will be equal to, we said that x of H is equal to 0, so epsilon of H is equal to I divided by B, which multiplies 0 plus A, so it is equal to A squared divided by B. This is a very important result, which we will now use. Now, we said up here that epsilon h, which is equal to 2r, is equal to 2ab divided a plus square root of a squared plus b squared. And on the other side, we found that epsilon h is equal to a squared divided by b. Now, equalizing these two expressions, we will get this equation over here. And now we do some simple calculations as we pass a on the right hand side, and we divide everything by b, and we will have that this expression over here is equal to 2 divided by 1 plus square root of b squared divided by a squared plus 1, which is equal to a squared divided by b squared. Now, if we put t equal to b divided by a in this equation over here, from this form we will go to this another form, which is 2, which divides 1 plus square root of t squared plus 1 is equal to 1 divided by t squared, where of course, as we said, we have put t equal to b divided by a. Now we can solve this equation over here for t, and by doing some simple calculation we let's say we cross multiply everything on this equation, and we will get that 2t squared is equal to 1 plus square root of t squared plus 1. Now let's pass 1 on the other side, and we will get that square root of t squared plus 1 is equal to 2t squared minus 1. Or that by taking the, let's say, by raising power of 2 both sides of this equation, we will get that t squared plus 1 is equal to 2t squared minus 1 all squared. And by doing some very simple calculations, we will reach this equation that t squared, which multiplies 4t squared minus 5, is equal to 0. This equation over here has two possible solutions, which are t equal to 0, which cannot be, because we know that b and a are different from 0, and so this expression cannot be equal to 0. And the other solution is the one accepted, that t squared is equal to 5 divided by 4. Now, what can we do with this expression over here? We want to find the ratio AB divided by BC. But up here we have said that AB is equal to the square root of A squared plus B squared, while BC in this case is equal to 2A, because we have expressed it over here. So by doing some simple calculations, we will get that this factor is equal to square root of b squared divided by a squared plus 1, all of it divided by 2. We multiply b squared divided by a squared, which is equal to t squared, which is equal to 5 divided by 4, and by doing some simple calculations, we will reach the conclusion that at the end the ratio AB divided by BC is equal to 3 divided by 4. So I know this is a little bit of heavy solution with some calculations, but as I said, this method almost always gives you a solution with a coordinative plan setup if you are not very good in synthetical solutions in geometry. So please let me know what do you think of this solution and maybe present your own solutions in the comment section. Thank you for your time and hope to see you on our next videos. Goodbye.